so I'm going to start. So thanks for coming, and my name is Julien Richard-Foy. I work at Scala Center, and I'm working on a re-implementation of the standard collections. So I'm going to explain in this talk what's going to happen internally, so that you understand what motivates the rewrite, and also externally, I mean, the changes that will impact end users like you, I guess. So first, in case you don't know what the Scala Center is, it's a non-profit organization dedicated to basically improve the life of Scala developers. So if you want more information, I invite you to check out our website. So yes, I'm going to explain what is this collection redesign work and the internal changes, the changes that will impact end users, and the remaining steps. So first, what is this redesign of the collections? The goal is just initially to reduce the implementation complexity and make them simpler to understand for newcomers. And also, while we do that, we still want to keep the basic usage mostly source compatible. So we don't want to break things as much as possible. This work is performed by Scala Center and Lightbend, and you can check out the GitHub repository online at this URL if you want. And yeah, so I'm sorry. This work is performed by Scala Center and Lightbend and lots of external contributors. And I'm really, really happy to have all these contributors. So a big thank you to everybody that contributes to the project. So, what is going to change? So first, the class hierarchy, and then how we manage lazy collection. So class hierarchy. You know that the collections are organized as a hierarchy. You have like traversable, iterable, seek, set, map, and then some specializations again. So if we just have a look at list, the intuition for list is that list is a special case of a sequence, which is a special case of an iterable, right? So intuitively, the model is as simple as that, but actually, the implementation uses lots of intermediate classes. So what happens is that for each node in the hierarchy, we actually require 4 implementation classes. For instance, for seek here, we have genSeek, seek-like, and then genSeek-like. And that's the same for iterable. We have genIterable, iterable-like, genIterable-like. So that makes maintenance a bit hard, and for users who want to just have a look at the hierarchy, it makes it harder also. So the new hierarchy is not as simple as that, but it's simpler than this one. It looks like that. So for each node of the hierarchy, we only have 2 implementation classes. So for list, we have list that extends seek, and seek is implemented with this seek and seek-ops trait. And that's the same for iterable, iterable ops trait. So you might be wondering, why do we need this ops trait at all? And actually, they are useful because that's what makes it possible to generically implement methods. Because if we take a look at 2 methods, like take and map, these methods are implemented in iterable ops, and the same implementation is reused by list and vector, for instance. But when you call take on a list, you want to get back a list and not an iterable. And if you call take on a vector, you want to get back a vector and not an iterable. So it has to, we want to abstract over the return type of the take method. So that's why we introduce this C type parameter here. It stands for collection type. And that's the same story basically for map, except that this operation can change the type of elements that are in the collection. So we have this CC type parameter, which stands for collection type constructor. Okay, and when we implement list, we just extend iterable ops, and we instantiate the CC type to list and the C to list of A, right? Okay. But you might be wondering, okay, why do we have two type parameters? It looks like we repeat list 2 times, right? But not always. So for instance, in the case of string ops, the type constructor is indexed seek, because if we call map on a string and we transform each character into a number, we cannot get back a string, so we can only get back an index sequence of int, for instance. And here the type is string, so that if we call take on a string, we get back a string. So yeah, this is it for the internal implementation about the hierarchy. So I hope it will make it simpler to understand. Now, second point about laziness. So currently, in the current collections, all the default implementations of operations and collections are implemented in a scheme similar to this one. So I'm not going to explain all of the details of implementation, but the important point is that this implementation is strict. It means that here we evaluate all the elements of the collections we are calling the method map on. And here we evaluate also all the elements of the collection we are building, the resulting collection, right? And this is not a problem because that's the semantics we want to have when we call map on a list. We already know all of the elements of the list, and we want to get back a list immediately. But there is also a concept of stream in the standard library, or there is also a concept of view that maybe few people use, but there are reasons to not use them, and I will explain that after. But the idea of these collections, stream and view, is that they are lazy. It means that we don't want to evaluate the element in those collections unless we really require them. So unless we really iterate on them, we don't want to evaluate them. And so this default implementation, which is strict, doesn't work at all with lazy collection. So that's a problem. And how do we manage that in the current collection? What we do is that so for instance, for the views, which are lazy, what we do is that we just override the operations. So here we override map in traversable view with an implementation that doesn't evaluate its elements. So the implementation is lazy. And then we have to pretend that the result of new mapped has the same type of that, and that is a type that is computed by the resolution of the implicit parameter CanBuildFrom. Okay, I will come back to CanBuildFrom later. And my point is just to show that we need to do a cast, and we have to carefully override each method which is strict by default to make it lazy, so it's error prone. And also, even though we don't use this implicit CanBuildFrom parameter, we don't use it in our implementation, we have to actually define an instance so that at use site the code compiles. And what does this instance do? It just throws an exception, as you can see here. It means that if users write code based on CanBuildFrom, and sometimes that happens, if that code is used with a view, then it will fail at runtime with an exception. So that's really a good reason to not use views, unfortunately. So yes, to sum up, currently in the collections, to work with laziness, we have to carefully override all strict operations to make them lazy. And we end up with unusable CanBuildFrom instances, which are dangerous to be available in the implicit scope. So how does it look like in the new framework? This is the actual implementation of map. So now what we do is that the default implementation is based on a view. So the default implementation is lazy by default, and then concrete collection types can decide whether or not to evaluate the elements in the view. So first, we call this view.map here, which creates a view of the mapped element of the collection without evaluating them. And then there is this from iterable operation that I will talk about later. So let's first have a look at view.map, because that's something new in the new collections. So basically, every operation that we have on iterators are reified as views. So you can just think of a view as a reified operation on an iterator. And the nice property of views is that views can be iterated on several times, not just once, like an iterator. And here we implement map by just calling map, delegating to map on the underlying iterator of the underlying iterable collection. Okay, so back to the implementation of map, the default implementation of map in iterable ops. So we call this view.map and then from iterable, and this from iterable method is an abstract method, and each concrete collection type then can decide whether or not to evaluate the elements of the view. So for instance, for list, from iterable will strictly evaluate the element of the view which is passed on, but in the case of view, from iterable doesn't evaluate the element of it unless we iterate on the view itself, right? So to sum up, in the new framework, we have default implementations of operations that works both with lazy and strict collections. So for us, it's less error prone. And now views, we hope views will become more popular because they are useful. Okay, so this is it for internal implementation details. Now I'm going to talk about changes that might affect your lives. So I choose, yes, to detail a little bit what happens with CanBuildFrom, and then I will talk about a few random other minor changes. So first about CanBuildFrom. So in the current collections, imagine that you are working with a list. So you want to know what you can do with the list, and you are having a look at the API documentation, and you see, okay, there is this map method here, which takes a function from A to B and gives me back a list of B. Wow, this is great. And then you start using it in your IDE, and you see the autocompletion tells a completely different story, right? And now you have that return type that you don't know about. Well, okay. And let's take another example. Let's say that now you work with a sorted map, for instance, a tree map. So you browse the documentation, and now you see, okay, there is a map method that takes a function from A to B. So do you know what a tree map is? It's a sorted map, so a map of key and values, and the keys are sorted. So there is an ordering relationship on the type of keys, A in our case. So yes, so you see in the Scala doc this map method that takes a function from A to B and returns a tree map of B. But what is a tree map of B? Tree map takes 2 type parameters, not 1. So there must be something wrong. And if you try it in your IDE, you will see, okay, yeah, the autocompletion tells me a completely different story again. And it's normal, because actually, the type signature that you see in the first case is a fake type signature. So we pretend that there is this type signature, but this is not a reality. And you can have a look at the full signature by if you click on full signature, and then you see the actual type signature of map, which is the same that you saw in the autocompletion. So why do we have that type signature? Well, because it's super powerful, actually. The really cool thing about this method is that it's defined once, and it works with string, with list, with sorted set, with sorted maps. This is amazing. But the downside is that we don't want to show that type signature to newcomers. So it's a bit scary. So how does the new map operation looks like? So in the new collections, if you have a look at the API documentation, you will see again this map method on list that takes a function from A to B and returns a list of B. And now if you try it in your IDE, yes, you have the same information, the confirmation about the type signature. Because indeed, that's not a fake type signature, but that's the actual type signature, right? Okay, and now what happens when you work with a tree map? Then you will see not one, but 3 variants of the map method. Why? Because we want to support several use cases. So, for instance, if we start with the first one, if your function returns a pair of key and values, and if it happens to exist an ordering relationship on the type of keys, then you will get back a tree map. Right? On the other hand, if there is no ordering for the keys, we cannot build a tree map. So the best we can return is a map. And finally, if you don't even return a tuple of a key and a values, we cannot even return a map. So the best we can return is an iterable. So now you will see 3 entries for map, and each entry will tell you the story of what it does. And autocompletion is now consistent with the documentation. So I hope it will be more approachable. So basically, we removed CanBuildFrom from our internal implementation. We don't use it anymore. But some of you maybe have used it internally in your code. It means that maybe we should not remove CanBuildFrom totally from the collections. I mean, even though we don't use it internally in the new collections, maybe it's useful for people. So how many of you have already used CanBuildFrom in their code base? Oh, not so many people. Okay. I'm a bit surprised because actually, so CanBuildFrom is also one of the basic building blocks for writing a generic code manipulating collections. So typically, we have 2 use cases. When we want to add a new feature to existing collections, whatever concrete collection it is, a list, a vector, or whatever else. And the second use case is when we want to get implicit builders for collection types. So let's have a look at how we can do that with the new framework. So there is no CanBuildFrom anymore, but there is something very similar which is named BuildFrom. And actually, it has exactly the same type signature and exactly the same method. New builder here is exactly the same as the previous CanBuildFrom, but you really want to use from specific iterable instead, because it allows you to preserve laziness of the concrete collection type that you are going to enrich with a new operation. Okay, so just to give you an example, without going too much into the details, that's typically how you are going to enrich collections with a new operation. So you use an implicit class, you take as parameter any collection type CC, which is a subtype of iterable, and then you define the extension method, and you require an implicit buildFrom that will compute the resulting collection type C for you, and then you call from specific iterable, and you pass it a view that lazily computes the result of the operation. Okay, that's the typical code that you want to write. Now for the second use case, TypeDriven Factorize. This is when you already know which collection type you want to build. For instance, I know I want a list. And in that case, you are going to use that new type, factory, which contains exactly, not exactly, but almost the same method as build from, but there is no notion of from, okay? And just for the sake of illustration, this is how you would typically use it to implement a generic JSON decoder with Play framework that decodes any JSON array into a Scala collection. Okay. So the important point is that here, so at use site, the user explicitly tells, okay, I want to decode some JSON data as a list of int or as a sorted map of that. And then this type is going to be the type C here. And this implicit definition takes as parameter an implicit factory for this collection type C. And this is how everything is tied together, right? Okay. So this is it for CanBuildFrom. Now a few, it's a bit like a list of items. So I hope it's not too boring, but let's iterate through these other minor changes. We have removed traversable. So who knows what's the difference between traversable and iterable? One guy, okay. What is it? Yeah, right. Yeah, exactly. So the difference between traversable and iterable is that in traversable, you have like internal iteration, whereas in with iterable, it works with external iteration. It means that iteration is controlled by call site, whereas in traversable, iteration is controlled by at definition site. And okay, so yeah, we plan to remove traversable. So if you have a good reason if there is a good reason you want to keep it, please tell us about that. And also, we are going to remove a few collections that we think are not used a lot, like double linked list or unrolled buffer or page collections. And yeah, so I mean, we do that based on our experience. So if your experience is different than ours, just tell us that maybe something is more useful than we think it is, and we will revise our decisions. Okay, important change, collection conversion. So in the current collections, when you want to convert a collection to a different collection, you can use a generic to method, but that to method takes a type parameter of the target collection type constructor, like vector. And the problem with this solution is that it doesn't work with map collection types, because maps take two type parameters and doesn't match the shape expected by two. So in the new collections, the to operation now takes a value, and as a value you can pass the factory method, I mean the companion object of any concrete collection type, so that it works nicely with both maps and vector list and so on. Okay. New cool method. We have a new operation that merges group by and map values. So now you can do, yeah, you can do that in one method call. Yeah, minor change. Stream has been renamed to lazy list to avoid the confusion with reactive streams, and also list informs about the internal structure of lazy list because it has this head and tail decomposition. Zipped, who knows about this zipped method here? So I have a vector, and now I create a tuple of collection, and I can call zipped on it. So who knows this zipped method? Wow, a lot of people. Okay, I wasn't expecting that many people. So, I'm sorry?
It's in the book, in the staircase book.
Yeah, okay, but okay. And so, what does it do? Why is it different from the usual zip? What's the difference with zip? You know? Yeah.
It's lazy.
Yes, it's lazy, and so there are two differences. It's lazy, so there is no intermediate zipped collection, and also it doesn't create tuples for the elements of the two collections that are zipped together. So here, the map method doesn't take a function that takes a tuple as input, but it takes a function that takes two parameters. And just by avoiding tupling and untupling, we can get some performance benefits. So it's basically 2 times faster than when you use zip and map in general. So my problem with zipped is that it's hard to discover. I mean, I didn't know about it, and I've been programming in Scala since several years. So if you want to know about it, either you found some code example that uses it, or if you try to just discover it by browsing the API documentation, you will not find it in the collections API. You will find it in the tuple API. So here you can find it in the API of tuple. So in the new collections, I wanted to make it easier to discover. So now the method is a method that's available on a collection, not on a tuple, and it's named lazyZip. So if you browse the documentation of any concrete collection type and you type zip, then you will see it in the list of results. And the same, if you work in an IDE and you start typing zip, it will show up in the auto-completion list. So I think it will be easier to find. Yeah, so that's a new difference. And last one, in-place transformation operations. So it's only for mutable collections. We are going to introduce a few operations that transform a collection in place. It means without creating a copy of the collection. Right? So that's an optimization. All right. So what are the remaining steps? The goal is to make them to ship them with Scala 2.13, which is supposed to be released in the beginning of 2018. And what we want to do, so far, this project is separate from the standard library. So you can start using it if you want to play with it. It's just like any library, Scala library. But we are working in moving it to the Scala library, to the standard library. Another change that I didn't talk about because we didn't made it yet. We want to change the default seek type to be to refer to the immutable seek one instead of the generic seek one. So for all collection type like set, map, Scala.set, Scala.map refer to collection immutable set, collection immutable map, excepted for sequence. This is just because of var args, just because of the way we manage var args. And so yeah, we plan to change that and make the default seek type to be the immutable sequence. Yeah. And finally, we will work on a migration tool that hopefully will make the migration path even smoother for end users. Yeah. And yeah, it's not too late if you want to contribute to the collection. If you think of a new clever algorithm or data structure or a new operation that you think is super powerful and super convenient that you don't want to re-implement in each of your projects, you can just create an issue to discuss about that. And if you are really impatient, you can scan this QR code and you will land in the GitHub repository. Yeah, so this is it. Do you have any question? Yes?
What is the status of when you apply several map in iteration?
Yeah. So yeah, so currently the semantics of strict collection is that each call of map will create an intermediate resulting collection. So in other words, chains of map calls will not be fused together, excepted if you use a view, which you can do, and in that case they will be fused. And you will traverse your data structure only once in that case. Would that work for you? Yeah?
What is the cost of translating list to a view?
Yeah, the question is what's the cost of turning a collection into a view? It's just one object creation. We just get a reference to the underlying strict collection, and this is it, yeah. Yeah.
So you said that the new collection library is not strictly coupled with the new Scala version, right?
Yes.
So it's going to be released independently in the future?
So no, the goal is to make it in Scala 2.13 as the standard library in Scala 2.13, yeah. Okay. Any other question? Yeah.
Is there any change to the Java reference?
Okay, so currently we just adapted the existing converters. So the existing converters are available in the new collections, but that might change. There is an ongoing discussion currently about that specific subject. So maybe I mean, if we don't have these converters, the idea would be to have implicit decorators available on Java collections, so that a Java collection can be used as a Scala collection directly without any conversion. Right. Okay. Okay. Yes.
There's a question about parallel collections, because you can't remove the generatorable, and with the command type for parallel tables and iterables. So how can we express that we have a piece of code that can manage with parallel collection or normal collection?
The question is about what's the status of parallel collection?
Yes.
Because the current hierarchy doesn't make it possible to abstract over the fact that a collection can be parallel or sequential. And the answer is that that's one of the items that remains to do. And so I have no precise answer yet, but anyway, we plan to migrate the parallel collection, so they are available as a separate module, and so we will support the parallel collection, but we might not have a common supertype for parallel and sequential collections.
And you plan to keep the conversion between normal collection to parallel collection with .par?
That's the idea, and you will probably have to add just an additional import statement at the beginning. All right. Okay, encore une question.
So I heard like maybe a few weeks ago that there was going to maybe be support for the traverse function as in traverse sequence Haskell like. Can you comment on that or the current status or something?
Yeah. So the first motivation for this work is to make things easier to maintain and to work on. But that's also because we are maybe breaking binary compatibility and sometimes source compatibility. It's also an opportunity to think bigger about huge redesign, like generalizing the traverse operation that's currently only available on future. We can only do a future.sequence. And my point of view is that I would love to have that traverse and sequence operations available on more than just future. But that will come with some complexity, so we are going to discuss and to make some experiments to see if it works well, if it's worth having it in the core collections or in the standard library or not. Yeah, it's more something about the standard library than about the collections. Yeah. Yes.
So this is basically the third rewrite of collections with Darcy. Should we expect another one when Dotty is going to be released?
Yeah, that's a good question. So is that the last rewrite of the collections? No, the goal is to have something that will work with Dotty as well, and that's not going to change a lot for Dotty. So we don't plan to do a breaking change for Dotty. Yeah. Okay. Thanks for your attention.